In the summer of 1999, deep in the Pacific Ocean, scientists recorded a sound they couldn't explain. A long, echoing signal that rose in pitch, stretched across thousands of kilometers, and didn't match any known marine creature or geological event. NOAA researchers gave it a simple name. They called it Julia. Julia was detected using the same underwater hydrophone network that once monitored Soviet submarines during the Cold War. These microphones can hear across entire oceans, capturing low-frequency sounds that travel for incredible distances. But even with such powerful equipment, Julia stood out. It was loud. It was unusual. And it didn't sound like anything in the ocean's acoustic library. The sound resembled a groaning, rising call, almost like something enormous was moving or shifting beneath the surface. It lasted for nearly a full minute, long enough for multiple senses to capture it clearly. But that's when the mystery deepened. Because although the signal was huge, its origin point appeared to come from an area near Antarctica, a region where few known biological sources exist. So what made Julia? One early theory suggested something biological, a creature far larger than the blue whale. Some even imagined a massive unknown animal producing a slow, rising call in the deep. But marine biologists quickly challenged this idea. Animal calls have patterns. Julia didn't. Its frequency, duration, and resonance didn't match whales, fish, or any living species on record. So researchers turned to geology. A leading explanation emerged. Julia may have been the sound of a giant iceberg scraping along the ocean floor. As enormous icebergs drift north from Antarctica, they can collide with ridges, canyons, and submerged mountains. This grinding can produce long, deep acoustic tones that travel astonishing distances. Julia's long, rising profile matched some known iceberg signatures. And the location where it was detected aligned with drift routes of large Antarctic ice masses. This became the most widely accepted scientific explanation. But even with that theory, questions remain. Julia was unusually loud, far louder than typical iceberg grounding events. The signal also had a smooth, continuous rise that researchers don't commonly see in similar recordings. And unlike the upsweep, Julia hasn't repeated. It was a one-time event. A single moment in 1999 that left behind no identical recordings. That one-off nature adds to the mystery. Because if it truly came from scraping ice, why hasn't a similar event produced the same acoustic signature since? Some researchers point to the possibility of a rare, catastrophic collapse, a massive chunk of ice fracturing or sliding along the seafloor in a unique way. Others note that the Pacific near Antarctica is still one of the least monitored and least understood regions on Earth. It's possible Julia's origin lies in a geological event we haven't fully documented yet. And then there's the smallest, but most intriguing possibility, that Julia came from an interaction between ice, pressure, and terrain unlike anything previously recorded. A natural phenomenon so rare that it may not happen again in our lifetime. Today, more than 2 decades later, Julia remains an unsolved acoustic event. A moment where the deep ocean revealed something powerful, and then went silent again. In a world where we map Mars better than our own seafloor, sounds like Julia remind us how little we truly understand about our planet. The ocean is vast. It's dark. And it still holds secrets that even modern science can't fully decode. If this mystery fascinates you, there's another ocean sound that's even stranger, a powerful, rising signal that repeated for years and confused scientists around the world. It's called the upsweep. And that story is already on the channel.